Task communication. Task communication in embedded systems refers to the exchange of data and control signals between different tasks or processes running on the same or multiple processes. Here are some simple steps to understand the concept of task communication in embedded systems. Identify the tasks. The first step is to identify the tasks or processes that need to communicate with each other. Each task should be designed to perform a specific function or set of functions. Choose a communication method. There are several ways to communicate between tasks in an embedded system. Some common methods include shared memory, message queues, pipes, and sockets. Choose a communication method that is appropriate for the system's requirements. Define the data exchange format. The next step is to define the format of the data that will be exchanged between the tasks. This may include the size and structure of the data, as well as any synchronization mechanisms that may be required. Implement the communication. Once the communication method and data format have been defined, it's time to implement the communication in the code. This may involve creating shared memory regions, setting up message queues, or establishing sockets. Test the communication. Finally, test the communication to ensure that data is being exchanged correctly between the tasks. This may involve creating test cases that simulate different scenarios, such as high data loads or unexpected errors. Inter-process communication. Inter-process communication, IPC, is the exchange of data between two or more processes in a system. In embedded systems, IPC is often used to facilitate communication between different parts of the system, such as between a microcontroller and a peripheral device. Here's a simple explanation of IPC in embedded systems. Shared memory. One common method of IPC in embedded systems is through shared memory. This involves creating a shared memory region between two processes, allowing them to read and write data to a common location. This method is fast and efficient, but requires careful synchronization to prevent data corruption. Message passing. Another method of IPC is through message passing, where processes send messages to each other. This can be implemented using various protocols, such as UART, SPI, or I2C. Message passing is slower than shared memory, but is easier to implement and less prone to synchronization issues. Semaphores. Semaphores are a synchronization mechanism used to control access to shared resources. In embedded systems, semaphores can be used to prevent two processes from accessing shared memory at the same time. For example, semaphores can also be used to signal events or to implement timeouts. Interrupts. Interrupts are a way for a peripheral device to signal the microcontroller that it needs attention. When an interrupt occurs, the microcontroller temporarily suspends its current task and executes an interrupt service routine, ISR, to handle the event. Interrupts can be used for IPC by having the ISR communicate with other processes in the system. By using one or more of these IPC methods, different processes in an embedded system can communicate and coordinate with each other, enabling the system to perform complex tasks.